Hey Honors Physics, a couple of you requested another chance to review how to solve systems of charges. What we mean by that is three charges in a line when we don't know the exact position of the middle charge. So what we're trying to find is basically where would we put charge 2 relative to charge 1, how far over would we put it, so that Q2 is at equilibrium with the two other charges that are pushing or pulling on it. So one of the key ideas is that if you're at equilibrium, then you have balanced forces. And that means any force to the left has to be equal to the right forces, or up and down. So let's take a look and zoom in, and if you watch the other video on how to find the free body diagram, you already reviewed this, but essentially what we do is we ask, what does Q1 and Q2 do to each other? Do they pull, do they attract, or do they repel? And you can see that a positive 8 and a negative 4 are going to attract each other. So let's draw the mutual attraction, right? It's a two-way attraction. So on Q2, which is the one we're interested in, we would write this as force 1, 2, and that's one of the two forces that is on the middle charge. Now, let's go over here and look at what do 2 and 3 do to each other? That is charge 2 and charge 3. And we're going to use blue for this. Well, we've got a negative 4 and we've got a positive 7, so they also attract each other. So the two blue forces are talking about just what does 2 and 3 do to each other, what direction are the forces. And we would label that as what is 3 doing to 2, and we could label this one, what does 2 do to 3? Well, it also attracts. So we kind of now zero in on the middle charge, and what you can see is that the middle charge is in a balancing act between the force to the right, 3, 2, and force 1, 2. The numbers stand for what charge we're talking about. So this is 1 pulling on 2 and 3 pulling on 2. Now, according to the statement, the given is that these two forces have to be balanced or at equilibrium. So one of the tricks we learned is that we essentially are going to have to set them up so that they're equal to each other. So what's equal? Well, the two forces, right? The force of 1, 2 is equal to force 3, 2. Okay, well that's not solvable. We don't know the forces, but we know a formula for what to plug in. So we know that we can use K, Q1, Q2, over the distance between them, but we already know that we don't know that distance. In fact, that's the unknown, and it's x squared. On the other side, we've got K, Q3, Q2, all over what distance? What's the distance between 2 and 3? Well, we don't know it, but we know that the total distance is 0.09 meters, but we could subtract x from it, and that's how you can come up with an expression for this unknown distance, the total distance minus the distance to wherever Q2 is located, and then the other distance, right? So this would be the x, let's clean that up. And this would be the 0.09 minus x. Okay. And we start to realize this is a pretty big problem, but we learn some skills. One of the first steps is we can cancel out factors that are the same on both sides of the equation. Okay, the K constant is the same for all Coulomb's law calculations. We also notice that Q2 is on both sides. So we really can simplify this down to just Q1 over x squared and Q3 over 0.09 minus x quantity squared. We also learned that you can get rid of these polynomials, these squared factors. Now you can't just make them disappear, but what you can do is you can square root both sides. What you do to the left, you do to the right. So we're going to have the square root of Q1 over what? Well, x squared square rooted is just x comes out. And then we've got the square root of Q3 over 0.09 minus x, and the square is gone. The square root takes care of that. We do need to plug in our 8 times 10 to the negative 6th, and we need to square root that. We need to plug in our 7 times 10 to the negative 6th, and we need to square root that. So we'll need to cross multiply, we'll need to simplify some like terms, and if you find the answer key, which is also above, it's on Monday on our agenda because that's when we were doing our review, you'll find the answer key to that. But from the standpoint of how to set up an unknown x position, it's step 1, draw the free body diagram right here. Then it's set the forces equal to each other. Write out your expression for how you would find F1 on 2, F3 on 2. Cancel, square root, and then it's algebra from there on out. And I know that everyone's got different skills, but I bet with careful manipulation, you'll get it all right.